Let's study something about universal constant of gravitation. Earlier we have studied that the value of G means the value of universal constant of gravitation, that is denoted by capital G, was determined by the experiment of Cavendish, and it is necessary that we should study the experiment of Cavendish, and I am giving you some arrangement of that experiment. So here is the arrangement in which the components are listed here. A rigid support which is of a long rod, and that is subtended with a thin metallic wire. So this is another component. And here what you see, A and B are nothing but the ends of the rod. And they are actually the small equal lead spheres. And you can clearly see from this figure that A and B are attached with the ends of the rod. Now two other equal large lead spheres can be brought into this arrangement, but you should have to keep it an opposite and equal distance. But before that, the force on the small spheres due to the large sphere means you can see the moments P dash, Q dash on the sphere, they are on large sphere. So they are equal and in opposite direction. So force on small sphere by large and the force on large sphere by small. So this is my result number 1. And here you can see with respect to the value of origin, which is either at the center of this coordinate system, and actually it is at the connected thin metallic wire. So when the rod rotates about the wire OM, then the wire is twisted and the restoring torque is producing in the wire. So this is the basic mechanism of the arrangement for Cavendish experiment. Now we will see this torque and analyze the remaining theory. When this torque due to gravitation force is equal to the restoring torque, then this system becomes steady. Or we can say that our system is in equilibrium stage. That means in this condition, the positions of large spheres, here the large spheres are P dash Q dash, are on the line perpendicular to AB. So here the lines what you have seen is the length of the rod was in this way. So the perpendicular lines will be this. So the position of P dash is now at this point and the position of Q dash is at the end of the another rod. Now the distance between their centers in equilibrium condition. So here is the AB takes place. So what I am going to find out? Distance between their centers means the centers of sphere in equilibrium condition is given by either as AP or either as in the form of PQ, that is small r. And when the rod is rotating, there is a twist in the thin metallic wire. So the angle of twist in a wire I am consider it as theta. The restoring torque per unit twist is small k and the length of the rod is AB, that is small l. And at last I am consider that the mass of large sphere as capital M and the mass of the smallest one is small m. And so the gravitational force on the small sphere due to the large sphere, that is Fsl, is equal to the gravitational constant G, capital M, small m over R square. So this is my result number 2. And now the total torque due to both spheres or due to both forces, which are the forces FSL and FLS, is given by G capital M small m over R square. You just have to multiply this force into length. And so the restoring torque tau is equal to k theta. And hence, in the equilibrium condition, this restoring torque is equal to the torque of the different forces. So in the equilibrium condition, Gmm over R square into L is equal to K theta. Therefore, the value of G you can find out from this equation is equal to K theta R square divided by M into L, that is equal to result number 3. And with this, our gravitational constant is in this form. So this is basically the value or the equation in which if you have the mass of large sphere, small sphere, and the length of the rod and this much quantity, so you can easily find out the value of gravitational constant. And here the restoring torque per unit twist, if you have to find out, then it is related with this equation. K is equal to tau over theta. So you can find out this much quantity also. And so by just measuring the angle of twist generated in thin metallic wire, we can find out the value of gravitational constant. And so the gravitational constant is depending on only on theta, because this much quantities will be same. But with respect to this theta, this r square is also changing. And so we will see such kind of phenomenon in the illustration which we are going to discuss just